Great, thank you. So I'm hoping by the end of this presentation that everybody else also understands. There's going to be a lot of background information kind of to start out. But first off, I'm Riley Kilmer. I'm one of the founders of Spur. We track anonymous access on the internet, so VPNs, proxies, residential networks, malware-driven proxies using home IP addresses, things like that, which kind of intersects with what I'm going to talk about today. And um, that's going to be how AI is now driving browsers to create almost human-like behavior, which goes against almost every single model that existing fraud detection solutions are trained against. Fraud detection is looking for inauthentic, non-fluid motions, and the thing is AI completely changes that. And so I'm going to dive into kind of what the existing technologies were, so like anti-detect browsers and what that means, talk about some of the types of risks and threats that we've seen in the past with these technologies and where they intersect with anonymity networks like VPNs and proxies. And then I'm going to dive in even deeper on now what does that look like as AI is starting to drive these sessions and the browser activity. So, like I said, we're going to start out with just kind of a level set. What is an anti-detect browser? So these are browsers that are meant to have lots of different sessions, and each one looks like its own independent fingerprint. Oftentimes they have proxy pools. So behind it, you give it, 100 different proxies. Each of your browser tabs or browser profiles has one of those proxies, and it will have a distinct fingerprint. So tools like Fingerprint.js, Arcos Labs, all these other ones that produce these machine identification, like try to do behavior-based IDs, not based on cookies and things like that, all look like distinct individual users. And so now you have one browser or one piece of technology that is able to scale out and do like, look like a lot of different people or a lot of different distinct profiles. And its goal is to defeat existing technologies. These aren't new, like I said. There's tools out there like Go Login, Multi-Login. They're enterprise grade. They have lots of user support so that you can have one instance across your enterprise and have any one of those people drive one of those profiles. It all has programmatic APIs and stuff to drive those browsers so that it can look as authentic as possible without ever having like it being visible or it rendering or displaying. Um, Go on to the next slide. We can talk about how AI can then be used to emulate user behavior. So this is now we have this programmatic environment that allows you to use APIs to drive browser activity. You have distinct fingerprints with the anti-detection technology. This is going to be like overriding APIs for screen resolution and things like that so that you can make it look like you're a mobile browser, even though it's running on a server somewhere. Um, AI can now start driving that session orchestration. So like do I start and stop for a specific profile? When do I switch to a different profile? Do I need to collect this information from a different country? Should I use a profile that proxies through the UK to get different data? Um, if this is going to be kind of a less exciting kind of example of why you might do that. But let's say you're crawling news sites and you get hit with a GDPR, like we don't support GDPR, you need to be coming from the United States. AI can then immediately switch to a different profile of a user that is based in Texas and proxy out of that Texas location and now no longer be blocked or restricted. Um, that's like I said, not as exciting of a way that AI can help drive this and automatically like switch between profiles, but that's something already that we're seeing. Um, Now, the human-like pattern inputs, a lot of the anti-fraud technology is looking for programmatic movements and things that are very um, I don't know, clunky, but now it's going to be more fluid because they can have mouse movements that actually emulate what a real human's going to do. Scrolling behavior that isn't just a consistent, constant scroll down the screen. There's going to be more of a like a pause for reading and things like that, so that they can render and not be stopped by fraud technologies that would normally catch the inauthentic behavior of scrolling through like news feeds or LinkedIn or Facebook or things like that that a lot of different scraping companies use. Now they're not restricted as much anymore because they can have that authentic looking interactions with the web page that the existing fraud technologies just aren't prepared to handle. Um, Now, if I take a look at some of the actual problems that we've seen. So, uh, one major issue that I've worked with telcos on in the past is uh, fraud involving SIM cards. So, talking to individuals in the help desk and essentially phishing and social engineering these help desk people to switch over a SIM card so that they can get access to two-factor to log into somebody's Coinbase account and drain it. So this is something that it already exists and is already happening, and it's human driven. So it's humans in the chat windows that are doing these conversations with the help desk support to try to do the social engineering. And one of the things that LLMs have been really good at is having that take over and scale it. So now instead of being able to do maybe, 20 attempts at social engineering a day, you can scale that out and do hundreds of attempts. Um, this is something that a lot of the ISP telcos and telcos are looking out for and are trying to make sure that they stop this kind of things happening before first line tech support makes a mistake like this and switches over a SIM card or gives access to an account that they shouldn't give access to yet. When it comes to credential stuffing, so this is going to be cases like we use info stealers and get a bunch of bank username and passwords and then applying those at scale. So this is just another case of existing fraud systems are looking for that inauthentic behavior. And using AI, you're better able to now programmatically take that list, apply it to proxies. So pick proxies that are at the correct locations and do this at scale. So if I have a bunch of accounts that I know for individuals, Bank of America customers located in Denver on CenturyLink or something like that, happen to use myself as an example here. So info stealers might have that pool of credentials. Now you use AI to automatically interface with the proxy services to find those CenturyLink connections in Denver and now start applying those username passwords all to the form inputs and then using that synthetic like behavior or that AI automated behavior, you start being able to trick the fraud systems and now they give an attempt. And then you rotate proxies, you rotate your profile within the anti-detect browser, and you start over once you tried something. So you never hit kind of like a rate limit, so to speak, because it's always a new IP address. It's always a new browser profile with new fingerprints. And it's always just going to be like, one set of credentials, like one username with a bunch of passwords or trying to replay cookies or things like that. Um, this credential stuffing is already an existing problem, but once again, it's just amplified by the ability of applying anti-detect browsers with these proxy services and all the different like info stealer data and stuff that's out there. Finally, synthetic identities. And this is going to be something that isn't necessarily as much like criminal, so to speak, or at least the examples that I'm going to give. But making more authentic profiles on like Facebook or LinkedIn for user engagement or really any reason that you'd want to have lots of different profiles on the sites, whether it's to, increase somebody's opinion of one thing or have something else try to get started to be trending, or just sales messages on LinkedIn that every one of us probably gets on a regular basis. Um, with these LLMs and AI, they're able to better create profiles, better drive that like authentic human looking behavior that is been missing from a lot of the identities that have been presented in the past, where accounts get created and messages get sent. Well, now, you can start perusing, you can start adding people, you can start doing a lot of different behavior that Otherwise, we just take a lot of time and you can automate this. So once again, this is something that already exists, but now you're able to do it at much larger scale because it's much easier to get realistic looking profile pictures, get realistic content that you post, try to get some real engagement before you start doing the campaign that you create these accounts for. So this slide might look familiar for anybody that joined my talk on Tuesday, but in case it isn't, I'm going to talk a little bit about, the third layer of this problem. So we've already talked about the anti-detect browsers. We talked about the AI-driven nature of the anti-detect browsers and what some of this causes. And now we're going to talk about the like final layers, like where do you connect from to make it look as authentic as possible? So there are a couple of existing technologies. Um, 10 years ago, everybody would be using a traditional proxy or a data center IP. And those are going to be things that are going to be located in known data centers, AWS, Google, DigitalOcean, Linode, all those. And oftentimes, the IP address that somebody's connecting from is also going to be IP address that they're exiting from, which is really, really easy to detect and to determine what kind of like behavior and stuff might be happening from there. Um, Also, even if you don't have a great list of like VPNs and proxies to block, just knowing that they're coming from a data center is already a big red flag, especially ones that don't really cater to the enterprises, because enterprise VPNs exist in Azure and other places like that, but you're not going to see an enterprise VPN coming out of Linode. That's just not very common. It's more common to host websites and things like that, not necessarily having human traffic coming from there. Um, Next up are residential proxies. And this is something that like Spur really tries to identify and drive home is that residential proxies are coexisting on real people's home IP addresses. To give this example, I have my phone and I go to the App Store and I download a solitaire game. And embedded in their terms of service is an agreement that I am selling my bandwidth to a third party. And the app developer of solitaire gets paid for that install based on how much bandwidth the proxy networks use through my phone. And so it's a way to monetize applications without the traditional advertising or other things like that. The original value add for a lot of these programs was, hey, don't show your customer, like people hate ads. So how do you monetize it without ads? Well, sell their bandwidth, let a proxy company use it. But what happens when you install that solitaire app? Well, now bank fraud is flowing through your home IP address, and unbeknownst to you, you're showing up on a list somewhere for activity that never was related to your actual, like your own usage. You didn't commit that bank fraud, somebody else did on your behalf. Um, a lot of these actually like residential proxies originated as malware that it was just another way to monetize malware. I stole credentials, I stole data. Well, now I can steal bandwidth access and sell it to other criminals that want to do their criminal campaigns. So there's a lot of different ways that residential proxies present themselves. But one thing to note is they're really hard to do something about because it blends in with real traffic. Like in the case that it's on my phone, I'm here at my house with my family, and uh, if a bank tries to block my home IP address for having a residential proxy on it, it's going to block my access, my wife's access, and everybody else's at the house. And so there's a higher risk for more friction for users, for real users, by using these residential proxies. It's harder for the defenders to make a determination of when should I just outright block something or when should I, raise the bar or things like that. So that's one aspect of a residential proxy. The other is everywhere my phone goes becomes a proxy. So if I travel from my house to Starbucks and I connect to the Starbucks Wi-Fi, now the Starbucks Wi-Fi is a proxy for one of these companies that has that SDK installed on my phone. Um, I leave the Starbucks and I can just go drive around for a while. Now, T-Mobile or Verizon or whatever my mobile network provider is now a residential proxy, and so on and so forth. So that gets us to mobile proxies. Mobile proxies are going to be when the phone is connected to a mobile network, there's going to be thousands of people on that IPv4 address. So if you thought blocking a residential proxy was hard, blocking a mobile proxy is likely to apply more friction to more users than any of the other ones. But in addition to the like my phone moved to a mobile network and it had a residential proxy on it, mobile proxies also have SIM farms. So literally racks and data centers filled with SIM cards that all have access to different mobile networks, mobile IP addresses. They're often used for like SMS fraud and other things like that. But it's kind of also then grown into, well, while I'm connected to the mobile network, I might as well do activity on the internet as that mobile IP address. So it's another way of monetizing an existing technology. Because, like I said, SIM farms aren't new either. They've been around for a decade, but now they're being applied to a different type of tech risk. So, what do we do about this? Now, at this point, we're looking at AI-driven behavior within browsers that you aren't able to differentiate or cluster together, driven by proxy networks that are coming from real home IPs like Comcast or CenturyLink or others, where now these AI-driven things can pick and choose routing based on what type of profile they want to fit. And victims are all over the place. A lot of these residential networks have millions of IP addresses worldwide to choose from. You never have to use the same IP address twice. So, what do we do about this? Uh, all this behavior is immutable. And like we or sorry, the all the AI behavior that you're going to see is going to be actual movement on the screen. It's going to be things that are very difficult to detect from a fraud standpoint. But at the end of the day, all of this traffic is still going through IP addresses. They're still going through proxies. And even if it emulates perfect human behavior, AI is not able to affect the way that packets move on the wire. So by starting to apply just network intelligence, you can ignore the fact that all the other technology and stuff is accelerating at a crazy rate and just focus on the aspect of network intelligence that we're already used to and apply that. Don't worry about the user behavior, the change in scale that these things are happening at. We're still able to apply network intelligence to this problem as we have always been able to. It's not really not much has really changed. It's just the number of these problems that are occurring is skyrocketed. So what we can do is start applying network intelligence across the board. So if we know that we have a fraud campaign tied to a specific actor, after the fact, we can look over that and go, hey, Oxy Labs is the problem because residential proxies were present on every IP address that were happening in this particular campaign. And that's one way of being able to do this at scale. You can also then start looking at other characteristics like things are coming from data centers, which are less sophisticated than the residential proxies. But you can start looking at all different aspects of the network connection and even dive deeper and start using session analysis. So Spur's tool Monocle actually dives into the session analysis, which I talked about on Tuesday. But now you're able to like ignore the fact that, like I said, all the AI driven behavior, you can start looking at it and go, hey, that's a residential proxy itself, and not affect the real users on that. So in the case of my house having that residential proxy on it, and I'm going from website to website, I'm not being impacted. But if somebody's using an AI driven browser, routing through a residential proxy through my phone, uh, session analysis is going to be able to see there's a difference. AI cannot change the way that how a proxy works. That's just fundamental. Uh, Proxies are going to be they're a different location that the real traffic is originating from, and the way that the packets cross the wire, the way DNS resolved, all of those are telltale signs of proxying, and we can still detect that and apply it to existing tools. ReCAPTCHA, HCAPTCHA, all of those types of things. I had an image that I saw, I think shared on LinkedIn a while back, that it was like somebody had a character pattern and they asked ChatGPT, what is this character pattern? And ChatGPT goes, this is a captcha tool designed to stop bots, it says. And then it was perfectly iterating what characters were in that image that you're supposed to put back in the web form. So all of those traditional tools are defeated, but at the end of the day, it's still being proxied through a service like Bright Data or Oxy Labs or AnyIP or going through a malware service. So we can just kind of separate these into two different problems, a behavioral problem and a network intelligence problem. And while we focus on just the IP addresses that are connecting into us and applying that network level intelligence, or even going that step further and talking about session analysis, we can see and split the buckets so we can have our good users and we can have our bad users and only apply friction when it's really necessary. So some of the different things that you can actually already do to apply this. So Monocle already integrates in with tools like Cloudflare, and we're about to release Akamai. So if you're already using those existing things, you plug them in as a Cloudflare worker or other things. And other tools, Monocle's not the only thing out there. Jaw 4 has been making a bigger appearance, and there's some technology and capabilities within Jaw 4 to be able to identify that proxying behavior or VPN technology. Um, so that is one way that you can apply it. Other ways is just doing IP context lookups, get that IP level intelligence, see that it's a proxy, and start raising the bar if it is one. You can even start putting them into a sandbox of like, hey, you're only able to view this number of pages at a time because we suspect you of having a residential proxy on it and you're scraping our service. Even though your crawling looks like it's human generated, we're going to put you in this kind of, bucket here. Um, Other things, I guess, a point two on here was calling the different threat intel APIs. So doing those lookups, seeing what if there's a VPN or an ASN associated with it. Um, there's a lot of other ways, like you don't need to just like bucket things into block or allow. You can do things as granular as you like. I like the idea of sandboxing. I like things of tag and continue for users of social media. If you're trying to track that information, one easy way, like, yes, they might have real engagement, this LinkedIn profile, and you're trying to analyze it. But if every time they log in is from a different IP address, maybe even the same geo region, because a lot of these residential proxies, you can specify the region, but you might be changing from IP to IP. So I might not have the same IP twice from Comcast in Denver, but it's still located in Comcast in Denver. So, uh, do you see that change happening for every one of these logins for these synthetic accounts? And start applying that threat intelligence to it. And like every one of these logins, it's a different IP address every time or every day, it's a different IP. Comcast doesn't give out IPs that frequently. Like I don't have that many DHCP leases or expirations that are going to happen. So tracking the fact that it is different IPs over and over for the same user, and all of them have the same threat intel characteristics. They all are tagged as a residential proxy. Um, yes, one user might actually have a residential proxy on their network, but to have that change of IP addresses every time they log in, and each one of those IPs also being labeled as a residential proxy, that goes from being, oh, it could be a coincidence to this is likely a threat actor using synthetic identities along with residential proxies to manage their accounts. Um, and also, you can, if you're in the financial institution like space and you're worried about that credential stuffing, you can tag that login having been done with a username or coming from a residential proxy. And if they try to do something like an elevated action, transferring money, especially for things like Coinbase or other crypto platforms, raise it up, require multi-factor in those cases. So if somebody is doing this credential stuffing at scale, you don't necessarily need to block that login. The real user will be able to enter in MFA. The real user will be able to do all these other activities if this is, stolen accounts at scale. Raise the bar. You don't necessarily have to block directly if you're doing session level analysis and not just IP based, you can go straight to blocking because you're less likely to be blocking the real user. Um, so if anybody wants to actually give this a try for themselves, go take out look at Spur's IP intelligence. You can just start plugging in IPs and getting intelligence right on our website without having to talk to anybody about it. And if you're fascinated by the idea of Monocle and doing session-based analysis, you'll also then be able to sign up for a couple million renders a month on your website. So if you want to see how much activity might be AI driven or just automated against your platform using these proxy services, throw the Monocle script tag on there and just look at the Monocle dashboard within Spur, and you'll start seeing that activity. And if you want to act on it, you'll have the tools to act on it as well. It's just uh, sometimes you want to see first before you go straight into the I'm going to block everything or I'm going to take action. Sometimes it's better to just listen and observe and see if there's a trend in problems before just jumping straight to actioning it. So if anybody has any questions, I'd love to answer them.
Thank you so much, Riley. That's a very, very interesting, fascinating topic that we covered today. I think we actually have some questions from the audience. I have my own questions too, but I'm gonna go to the audience first. Given that AI can emulate user behavior but cannot alter the immutability of network traffic, how could a security system leverage correlations between device, location, and identity signals to identify or distinguish between legitimate human activity and AI-driven proxy masked traffic, even when both exhibit a similar behavior at the application layer?
Wow, that's quite the question. Very long. I also have it pulled up and I'm looking at it as well. So one of the ways that you could actually handle that is looking for differences. So in the case of proxying and network behavior, AI is really good at this, but something to look for because if it's missed, does the time zone match the actual location that things are coming from? So if somebody is proxying through Dallas, Texas, is it going to be a central time zone time on the browser? As well as like GPS is often faked in mobile devices. A lot of the anti-detect browsers actually overwrite the GPS capabilities so that you can emulate yourself coming from anywhere. So you can match that proxy location. However, a lot of proxy providers, you might say that you want Dallas. They're not necessarily as good. And you end up in Houston or San Antonio. And those little discrepancies are things that you can look for. And by applying network intelligence, you can start seeing that like there's that trend of, hey, this is coming from a residential proxy. And some of these things aren't lining up quite right. I'm going to go ahead and block this session.
That's great. That's a great answer. Like paying attention to all of these little signals, right? To see if there's any discrepancy or something
Absolutely.
odd.